Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from November 2015 sequence and series questions. November 2015 sequence and series, that is question number 2 and 3. So listen very carefully. Let's start question number 2. The following geometric sequence is given by 10, 5, 2.5. So there is a geometry sequence given like this, that is 10, 5, 2.5, 1.25, etc. So it is given, already given in the question, that this one is a geometric sequence. So if it is a geometry sequence, can you say what you can find? Is it a common difference or a common ratio? Of course, it's a common ratio. Am I right? Okay. So how can you find the common ratio here? This is the second term divided by first term. Is it not like that? You can find the common ratio. Common ratio is T2 divided by T1. So what is T2? 5 divided by 10. So 5 by 10 is 1 over 2. So it means that it is given in the question that this one is a geometric series. So sequence. So if it is a geometry sequence, of course you can find a common ratio. How can you find the common ratio? T2 divided by T1. So it is 1 over 2. So in this geometry sequence, the common ratio is 1 over 2. You understand? Okay. Now look at the first question. 2.1. What is that question? 2.1. Calculate the value of the fifth term of this T5 of this sequence. You have to find the value of the fifth term. So here you can see this is the first term, second term, third term, then this one is the fourth term, and you have to find the next term, that means the fifth term. So how can you find? In a geometry sequence, how can you find the next term? For example, here first term is 10. Okay, so first term is 10. Now to find the next term, you just multiply that first term with the common ratio. Here the common ratio is 1 over 2, and that is how you are getting the second term. To find the third term, that 5 times again the common ratio, and that is how you are getting the third term. You understand? So to get the next term, you have to multiply with the common ratio. So here, how can I find this term, next term? You have to multiply this 1.25 with 1 over 2 or half. Okay, so to find that fifth term, I have to multiply 1.25 with 1 over 2, the common ratio. Check in your calculator what is answer. 1.25 times half, 1.25 times 0.5, 5 over 8. So it means that the next term is 5 over 8, or in decimal 0.625. So that is equal to 0.625. So either 5 over 8, you can leave it like that, or here all the numbers are written in decimal. So that's why I write 0.625. Okay. So that is first question 2.1. Now let's move to the next question 2.2. Question number 2.2. What is that question? Calculate the nth term Tn of in terms of n. You have to find the nth term. So in a geometry sequence, what is the formula to find the nth term? Tn. You studied a formula in grade 10. A into r raised to n minus 1. So you have to write the nth term in this question in terms of n. So here Tn is equal to A, first term. What is the first term? It is 10. 10 into what is r? We got the value of our common ratio as half. Half raised to n minus 1. That's enough. Okay. So what is Tn, guys? Let me write it here. Tn is equal to 10 into half raised to n minus 1. Okay, just leave it there. Okay, in case if you want to use that one, we can use it later. Okay, so that is 2.2. now let's move to the next question, 2.3. Question number 2.3. What is that question? Explain why the infinite series 10 plus 5 plus 2.5 plus 1.25 plus etc. converges. So you have to explain why this series, the same series, the same numbers, they add that numbers 10 plus 5 plus 1.25 plus etc. and now you have to say why this series converges. Okay, so when can you say that a geometric series is converging? If the value of r, if the value of geometric series for convergence, in the case of a geometric series for convergence, the condition is the value of r must be between -1 and a +1. That is a condition for a convergence. The common ratio must be between -1 and a +1. So here what is the value of r? Here we know that r is equal to 1 over 2. It implies that -1 is less than half less than 1. Therefore, the secant, that means the condition satisfied because half is between -1 and 1. So therefore, the given series converges. So you have to know this condition for convergence. The value of r or the common ratio must be between -1 and a +1. Okay, so that is question number 2.3. now let's move to the next question, question number 2.4. What is that question? Question number 2.4. Determine S infinity minus Sn in the form of a b raised to n. So you have to find, question number 2.4, you have to find S infinity minus Sn. What is S infinity? Sum to infinity. Okay, and what is Sn? Sum of the first n terms. Okay, so here this is a geometric sequence. So how can you find sum to infinity? There is a formula you studied, sum to infinity formula. What is that? A divided by 1 minus r. This is the formula to find the sum to infinity. Minus, what is the sum to first n terms? Sum of the first n terms. There is another formula you studied, a into 1 minus r raised to n divided by 1 minus r. Am I right? So this one is the formula to find sum of the first n terms, and this is the formula to find the sum to infinity. So here you can see 1 minus r is a common factor. So take that common factor 1 minus r, then same denominator. So you can just write the numerator as it is, a minus a into 1 minus r raised to n. Expand the bracket. So it is a minus a into 1 is minus a into minus r. So it is plus a into r raised to n. Minus into minus is plus a into r raised to n. That is this one. Divided by 1 minus r. So here you can see minus a and plus a you can cancel. So what is remaining? A into r raised to n divided by 1 minus r. So that is now we have to substitute. We know all the values. We know what is a is 10, first term, and what is r? Common ratio here we got as half. Okay, so now we can substitute the values. So those who didn't write this one, you have to pause the video and write it. So now we can substitute the values. What is that one? Is equal to a into a is first term, 10 into r. R is half raised to n r raised to n divided by 1 minus r, 1 minus half. So here you have to simplify. 1 minus half means half, am I right? Or check in your calculator, 1 minus half is half. So 10 into half raised to n divided by half. So now look at this one, 10 divided by 1 over 2. So how can you simplify that one easily? In another video I already told you how to simplify that one easily. Look at this one. Anyway, listen once more. 10 divided by half. Okay, so when it is something like this, you just take these 2 and multiply with this 10. Okay, so 2 times 10, that is 2 times 10 divided by this number. So it is 1. Okay, what is 2 times 10? It is 20. 20 divided by 1 is 20. Okay, so this one, the answer is going to be 20. I'll explain that one once more. So here this is 20, then half raised to n. So now we can see that they want the answer in the form of a into b raised to n. So here a into 20 into b raised to n, that form is that. Okay, so that is question number 2.4. okay, now that the one that I explained before, let me explain once more. Try to understand like this. If there is something like this, a divided by b by c, if it is something like this, the easy method to do is you just multiply these two numbers. Okay, so it is a times c divided by this denominator b. You understand? But you must be careful. If it is like this, a by b divided by c, something like this, okay, then what you are supposed to do is you multiply these two. That means b times c. Then you are supposed to write the answer a divided by b times c. Okay, so you have to understand both the cases. Okay, then when this type of questions comes, we can easily answer without writing much step. Okay, or you can use your calculator, you will get the same answer. Okay, now what is question number 3.1? Consider the series Sn is equal to. So there is a series given like this. Sn is equal to minus 3 plus 5 plus 13 plus 21 plus etc. How many terms are there? N terms. So it is given that there are n terms. Okay, so there is a series given like this. First term minus 3, 5, 3, 13, 21, etc. Okay, and it's a series. Series means plus 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 plus. Okay, so what is the first question? 3.1. Question number 3.1. What is that question? Determine the general term of the series in the form of. You have to write the general term. So general term means in the form of tk is equal to bk plus c. In the form of what? Tk is equal to bk plus c, something like this. You have to write something like this. Okay, so in effect you have to write the general formula, that's all. Okay, so in the form of tk is equal to bk plus c. So now look at this series. First of all, you have to identify what type of series is this. Here look at this one, second term minus first term. What is that one? 5 minus 3, 5 plus 3, that is 8. Third term minus second term, 13 minus 5, that is also 8. 21 minus 13, that is also 8. That means this one is a arithmetic sequence with a common difference 8. Am I right? Okay, and what is the first term? A is equal to, first term is minus 3. Okay, and the question is to find the general term. Okay, so if it is an arithmetic sequence, what is the formula to find the general term? Yeah, you know that it's Tn is equal, this is the formula you studied, Tn is equal to A plus n minus 1 into D. Okay, the only difference in this question is this is the formula that in almost all the schools you are following. Okay, but the only difference from this one and this one is instead of n they wrote k. Okay, doesn't matter n or k or l or m or whatever may be. Okay, so we can write instead of this n we can write t k is equal to a plus n. So there also you have to write k minus 1 into d. In effect there is no change in the formula. Okay, they just change the notation, that's all. Okay, instead of n they wrote k, that's all the difference. Okay, now we can substitute the values that we know. Tk is equal to a, what is the first term, minus 3 plus k minus 1 into, what is the common difference, it is 8. So Tk is equal to, now we can expand the bracket, 8 into k is 8k, 8 into minus 1 is minus 8. So Tk is equal to, let's write 8k first, minus 3 minus 8, that is minus 11. So what is the general term? Tk is equal to 8k minus 11. Okay, so that is the first question. So let me write the general term here. Tk is equal to 8k minus 11. Okay, in case if you want that one in the next question, then we can use that one. Okay, so now that is 3.1. now let's move to the next question, question number 3.2. What is that question? Write Sn in sigma notation. You have to write this Sn in sigma notation. So sigma notation, Sn is equal to sigma n is equal to, here first term, that means n is equal to 1 to how many terms? Here you can see that it's written here n terms. So here sigma n is equal to 1 to n. So here it is written k. So instead of this k we can write k is equal to 1 to n. Okay, so sigma k is equal to, because they wrote in terms of k. Okay, so here you have to write k is sigma k is equal to 1 to n. N means this n means it is given in the question that there are n terms. Okay, normally we are writing sigma k n is equal to 1 to 5, sigma n is equal to 1 to 50, like that. Okay, what is the last, how many terms are there, that is this one. Okay, from where to where. Now here we have to write in sigma notation. So this is an arithmetic sequence, and here what we are supposed to write, the general term. So previous question we already found the general term here, 8k minus 11. So you can, it's easy now. Here you just write 8k minus 11. Here you are supposed to write the general term. So previous question we already got the general term, 8k minus 11. Okay, so that is question number 3.2. we have to write the answer in sigma notation. So this is the sigma notation. Okay, so that is question number 3.2. now let's move to the next question, question number 3.3. what is that question? You have to show that, look at that question, show that Sn is equal to 4n square minus 7n. You have to show that Sn is equal to 4n square minus 7n. Okay, so what is Sn means? Sum, am I right? Okay, sum of what type of sequence is this? Arithmetic sequence. What is the formula to find the sum of an arithmetic sequence? Sn is equal to n over 2 into, I hope you know this formula, 2a plus n minus 1 into d. Am I right? This is the formula to find the sum of an arithmetic sequence. Am I right? Okay, so here we can substitute the values. We don't want to substitute anything for n because they want the answer like that, Sn is equal to. Okay, so Sn is equal to n over 2 into a. What is a? First term is minus 3 plus n minus 1 into d. What is a common difference? Previous question, do you remember? We got 8 as common difference. Okay, so into 8. So here Sn is equal to n over 2 into 2 times minus 3 minus 6. Expand the bracket. 8 into n is 8n. 8 into minus 1 is minus 8. So Sn is equal to n over 2 into 8n. Let me write this 8n first. Minus 6 minus 8. So it is minus 14. Now we have to expand the bracket like this. N over 2 into 8n. N over 2 into 14. Okay. So what is this n over 2 into 8n? This 2 and 8 cancel. Here it is 4. So 4 n into n is n square. So it is Sn is equal to 4n square. Then what is n over 2 times minus 14? N over 2 times minus 14. This 2 and 14 cancel. So it is remaining 7. So n into minus 7. That is minus 7. So now we can see that this is actually what we want to prove. Sn is equal to 4n square minus 7. We got the same 4n square minus 7n. Okay, so that is question number 3.3. Now let's move to the next question, question number 3.4. Let's move to the next question, question number 3.4. Another sequence is defined as q1 is equal to 6, q2 is equal to 6, is it 6 or minus 6? Minus 6. Minus 6 plus, sorry, minus 3. Let me write it once more. So q1 is equal to minus 6, q2 is equal to minus 6 minus 3, q3 is equal to minus 6 minus 3 plus 5, q4 is equal to minus 6 minus 3 plus 5 plus 13, q5 is equal to minus 6 minus 3 plus 5 plus 13 plus 21, q6, that is not given. Okay, so there is another pattern given like this, and they call this one as q1, q2, q3, q4, q5, like that. Okay, so here what is q1? Minus 6, q2 minus 6 minus 3, q3 minus 6. Can you see that this one is repeating? Minus 3, then plus 5, then q4 minus 6 is repeating, minus 3 is repeating, plus 5 is repeating, then there is a plus 13. Okay, q5 minus 6 minus 3 plus 5 plus 13, then there is a 21. Okay, now what is the question there? 3.4.1. question number 3.4.1. what is that question? Write down a numerical expression for q6. You have to write what is a numerical expression for q6. So anyway, only one difference is going to be this minus 6 is same here, minus 3 same, 5 here, 13 here, 21 here, and we just want to add one more term there. That's the only difference in q6. Okay, so minus 6 same, minus 3 same, plus 5 same, plus 13 same, plus 21 same. Then here what is another term? Can you see that every time they add one more term? Minus 3, then add this one, 5, then add this 13. Okay, then 13 up to 13 is here, then add one more term. So up to 21 is here, then we have to add one more term, that is q6. Okay, so how can you find which number I have to add? So here you have to think logically. This is a logical type question. Look at this one. Minus 3. Look at the Sn, the given than previous one. First term is minus 3. Look at this one. Minus 3 plus 5. Minus 3 plus 5. Minus 3 plus 5 plus 13. Minus 3 plus 5 plus 13. Can you see that? Minus 3 plus 5 plus 13 plus 21. Minus 3 plus 5 plus 13 plus 21. Can you see that? So apart from this minus 16, minus 6, okay, if we avoid this minus 6, that is actually our Sn. From here our Sn. Okay, so in that Sn, what is the common difference we got here? It is 8. You remember that one. So here minus 3 plus 8 is 5, 5 plus 8 is 13, 13 plus 8 is 21. So to find the next term, 21 plus 8, 21 plus 8 is 29. You understand? So only difference is they added a minus 6 before that. That's the only difference. Okay, so what is Q6? Let's write Q6 once more. So it is minus 6 minus 3 plus 5 plus 13 plus 21 plus 29, and that is the answer. Okay, so that is 3.4.1. now let's move to the next question, 3.4.2. Question number 3.4.2. what is that question? Calculate the value of Q129. You have to find Q129. What is the numerical value? What is the answer there? Okay, so here Q6, Q7, Q8, Q9, Q10, Q11, Q12, like that, etc, etc, etc. There is Q129 here. You understand? And what is the final answer when you, not to write like this, not the expanded form? Okay, what is the, when you use calculator to find the answer here? Okay, similarly when you find the answer here, what is the final numerical value? What is the answer there? Q129. Okay, so for that what we can do is this Q129 means what? There are 129 terms there. Am I right? Okay, so this Q129 means in that here there are 129 terms. Okay, so that 129 terms, first term is minus 6. Am I right? Okay, then total how many terms are there? 129. Okay, so first term is minus 6. Then how many terms are there? 128 terms, because this is the first term, minus 6. Okay, plus 128 terms. Is it not that 128 terms from here, for example here you can see that from here this is actually Sn. Am I right? Minus 3 plus 5 plus 13 plus 20, 21. Okay, so similarly these remaining terms here, it is from Sn, and from that Sn how many terms remaining? It is 128 terms. Do you understand? So Q129 means first term is minus 6, then plus, that means one term is here. Total how many terms are there? 129 terms. Okay, so remaining 128 terms here, like this, minus 3 plus 5 plus 13 plus 21, 29, etc, etc, etc. Okay, so is it not that one is our Sn? Can you see that, etc, etc, etc? Okay, how many terms remaining? 128 terms, because first one term is here, so this one term plus 128 term, that is Q129 terms. You understand? Now I am thinking, anyway we have to find the answer of this one. Okay, so how can I find this S128? Previous question we already got an expression for Sn. What is that expression for Sn? Sn, question number 3.3. look at question number 3.3. we got an expression for Sn. What is that one? 4n square minus 7n. So how can I find S128? S128 is equal to, I can substitute the value of n as 128. So it is 4 into 128 square minus 7 into 128. So check in your calculator, what is the answer for that one? 4 into 128 square minus 7 into 128, 64,640. So that is S128. Okay, but our question is not to find S128, our question is to find a Q128. So therefore Q128 is equal to minus 6 plus S128. What is that one? 64640. So it is 634 minus. So it is 634. So that is Q120, sorry, not 128, it's 129. So Q129 is 64,634. So guys, that's the end of November 2015 sequence and series questions. So I hope it is not that much tricky, only this one is, last one is little bit tricky. It's not like a 2014 questions. Okay, so I hope all of you understand clearly. Thank you for watching. Keep on watching. Practice maximum number of questions. Okay, so see you on the next lesson. Bye.